Let's take a look at how to solve a system of three equations. So when the directions ask you to solve the system, we have three equations and three unknown variables, x, y, and z. We need to find values of x, y, and z that will satisfy not only this equation but these other two as well. And that triple needs to satisfy all three equations at the same time. And the method we're going to use to do this is, which we've learned in the past, is our elimination method. Elimination sometimes is called the addition method as well. So when we eliminate, we're looking for coefficients that are opposites of one another. So in a system of three equations, you basically want to work with two at a time. So right now I'm looking for coefficients that are opposites of each other. I lined up all my x values here. So I have 7, 3, 5, 5, negative 5, 3, negative 3, 2, and negative 7. And I notice that these two right in here are opposites of one another. So let's add these two together. We'll bring them over here. I'll rewrite them quickly. And it's always important to keep things lined up vertically. If you don't, they can get a little bit confusing. So here we go. We're going to add these. 7 and 3 is 10x. 5y and negative 5y cancel out. So that's a good thing. That's the elimination step. Negative 3z plus 2z is negative 1z. 16 plus negative 8 is positive 8. So we're left with 10x minus z equals 8. Alright, so we eliminated the y variable there. If you eliminate the y variable in the first step, you want to try to do that in the second step as well. So what we're going to do is look at the bottom two equations, these two now, and then we're going to try to eliminate the y variable again. So in order to do that, we're going to need to make these two coefficients opposite each other. Well, in order to make them opposite one another, we need to kind of think about their lowest common or least common multiple, which is in this case 15. So I'm going to want to make this one a negative 15 and this one a positive 15. In order to do that, I need to multiply the top one. I need to multiply the top one by 3 and the bottom one by 5. So here we go. I'm multiplying the top equation, all four terms, by 3. I get 9x minus 15y plus 6z is negative 24. The whole bottom equation by 5. 25x plus 15y minus 35z equals 0. And add those together. 34. Let's see, those things are opposites of one another, which means they cancel out. So I've got positive 6z minus 35z. That's going to be at negative 29z. So what we're left with is a red equation that has x's and z's, a black equation that has x's and z's. I'm going to move the red equation up here and just kind of rewrite it. And now we are ready to solve this system right here. This is a system of two equations with two variables, so it's a little bit more traditional. So again, we're going to either use elimination or substitution, or you can use some other stuff too, but what I'm going to do here is I'm going to use substitution. Alright, so I'm going to take this up here. Actually, scroll down a little bit. I'm going to solve this system by substitution. When you solve by substitution, you need to get a variable by itself. The reason I choose that is because this variable right here, z, has a coefficient of negative 1. So we can solve for that really simply. So if we kind of bring this whole equation over, I'm going to move. Let's rewrite it first. my goal here is to get z by itself. So I'm going to subtract 10x from both sides. These cancel, leaving me with negative z. These cancel. So we have negative z is equal to, let me do that again. These cancel. Negative z is equal to negative 10x plus 8. And of course, if the z is negative, we don't want it negative, we want it positive, so that changes the sign of everything else. Alright, so the substitution method, really simple stuff. Once you've got the z solved for, all you need to do now is take that thing, take that z, and replace it right there. And then rewrite the red one. So here we go. I'm going to rewrite this equation. Instead of using z, I'm going to replace it with my big green box here. 10x minus 8. Alright. And solve this. So we've got, let's see, 34x minus 290x plus, let's see, 160 plus 72, 232, I think. Check that again. 160, 72. Yeah, that seems right. Alright, so next thing, let me get that out of there. All we want to do is combine these like terms. We got 34x and negative 290. That's going to be negative 256x. I'm a little rusty here coming off the summer with my arithmetic. And we'll solve. So these cancel. I'm getting negative 256x. These cancel. And alright, that's great news. That is negative 256. So we'll divide by negative 256 on both sides and get x is positive 1. Alright. So that is one answer. Cool. We need 3 though. We need the y and the z as well. So once you have one answer, look for places where you can plug it back in. We already have the x value, so how about we plug the x right in there to get the z variable, the z value. So here we go. Let's go with purple. Let's go z is 10 times the value of x that we just got. The value of x is obviously just 1. So 10 times 1 is 10. 10 minus 8 is 2. So z is 2. Great. And finally, I'm looking for the value of z. The value of z, excuse me, that's not true. I'm looking for the value of y. So we kind of have to go all the way back up to the top here somewhere. And we have a y right here, here, and here. Totally up to you where you plug in your x's and your z's. But basically we're using the two values that we just calculated to find our last remaining value. So I'll just use that last one right. I'll just use this equation right here. And I will plug in my value for x, which is 1. I don't know y, and my value for z, which is 2, equals 0. So 5 plus 3y minus 14 equals 0. 3y minus 9 equals 0. 3y equals 9. Y equals 3. Alright, so that was kind of a lot, but if we bring it all together here, we can see that as a final answer, we'll put our ordered triple in this order, x comma y comma z. So we have 1 comma 3 comma 2, put parentheses around it, and since it's a final answer, you want to say that it's a solution. And you're all set. Alright, the really good students are going to take all those values, take them back up here, take 2 seconds to plug them back in. Right, so I'll show you that very quickly, just to check your work. We'll do the first one right here. So the first check, remember we have values that are, let's see, x is 1, 3, and 2. 1, 3, 2. So every time I see an x, I'm over here in this equation. Every time I see an x, I'm going to replace it with a 1. So 7 times 1 plus 5 times 3 minus 3 times 2 should equal 16. Let's check it. 7 plus 15 minus 6. 7 plus 15 is 22 minus 6. Yeah, that works. That's a good thing. You would do the same for this equation, the second equation, and the third equation as well. And once you do that, you'll realize that your answer is absolutely correct. So that's it.